This pre-calculus lesson is speed and word problems with converting. The first thing that I want to mention is the difference between linear speed and angular speed. Linear speed means distance with respect to time. So, for example, maybe miles per hour, which you can abbreviate, of course, as MPH. You could also do kilometers per hour, which would be KPH, or maybe meters per second. Okay, so if you see one of these little abbreviations, please know what that means. These are the things that we're used to. You go a distance, a flat distance with respect to time. Now, more interesting is angular speed. And so with something like this, you take a rock, you take your keychains or your lanyards, and then you whip them around your head like this, around and around. And so what you're doing is you're going around at a certain angle, around a circle with respect to time. And so you could do this as degrees per second, or maybe radians per minute. But these are the two ways to represent an angle. Okay, so you're going round and round. That's pretty fast, but you're not getting anywhere. You're just doing angles. Okay, let's talk about a revolution. In terms of a circle, if you go once around, that is a revolution. One time around a circle. Okay, one time around a circle. Here's something interesting. You need to know this abbreviation. RPMs stands for revolutions per minute. Sometimes people say rotations or something. It's technically called revolutions per minute. And a revolution is once around a circle. That's a revolution. So we're going to be dealing with circles. So we definitely have to talk about circles a little bit. Okay, let's talk about the angles of a circle. So if I go once around a circle, how many degrees could I say that is? That would be 360 degrees if you talk angles. What if I go once around a circle? How many revolutions is that? That would be that would be radians. One revolution would be 2 pi radians. Now that's if you talk in terms of angles. What if I talk about length? So if I go once around a circle, okay, that would be like circumference. And so the length around a circle would be 2 pi r units. This would be degrees, this is radians, and then this is units if you want length. So when you're doing word problems, you have to read if they want angles, degrees, radians, or if they want it in terms of length. Okay, let's just talk about some other differences here so we know what we're dealing with. A statute mile. This is the regular one. This is the land mile versus a nautical mile. A nautical mile is a water mile. And a water mile is usually abbreviated N and then mile, nautical mile. And if you're driving a boat in the water and you're going so many nautical miles per hour, does anybody know what they call that, the speed of a boat? Instead of saying nautical miles per hour, they call that knots. So if you ever see the word knots, that's just them saying miles per hour for a boat. Something else we have to talk about, this might come up a little bit. Navigation and the world in general works different than us people here in the math classroom. So when we're in the math classroom, we really care about starting our angles on the x-axis. That's where we like to start. And then if you want to draw a positive angle, we will swing up into quadrant 1 first. So this is what a 30-degree angle would look like in the math classroom. But the world does not work that way. If you're driving a boat or a plane, then people out in the world, they care about due north. This is where they start. And if they're going to be on a course or a bearing of 30 degrees, their 30 degrees goes this way, and so their 30-degree angle is going to be in a different spot than ours. Okay, so navigation, they like to start with due north, and then their positive angles swing to the right. It's still into quadrant 1 first. Okay, that's a nice little preview of everything. To do all of these problems, we are going to do unit conversion tables. This is by far the easiest way to handle these problems. Some of you may have seen this if you've done chemistry or you've done some unit conversions. It works the same. If you know how things are related, you don't have to memorize any formulas. All you have to know is where you start and where you're going. Okay, so let's read this question carefully. A child is spinning a rock at the end of a 2-foot rope. So the first thing I always need you to do is draw a circle. We have a rope that's 2 feet long, and then he's spinning it round and round. Okay, so that's our circle. And the rate is 180 revolutions per minute. So we have a problem here where we're given revolutions per minute. And we have to find the linear speed in miles per hour. So our goal here is to change revs per minute into miles per hour. Okay, this is the key. So step 1, you draw your circle. Step 2, you figure out what units you're starting with and what you're converting them with. If you can figure this out, you're halfway there. You know what you're going to be doing here for this problem. This is how the conversion tables work. Okay, you draw a nice long bar. You put what you have here. We have revs per minute. So we've got revs per minute, and this is what we're going to convert it into. If you can do that, you'll be done. Okay, how many revs per minute do we have? 180. So the number's always going to go there in the top over 1 minute. Okay, let's get started. Would you guys like to change revolutions into miles first or minutes into hours? Most people tell me, let's do minutes because I like that when it's easy. Okay, minutes have to go away. I want them to cancel. If I want them to cancel, I'll have to have some minutes here in the numerator to make that happen. And I'll put minutes into hours. Then you ask yourself, how many minutes are in 1 hour? And that would be 60. The minutes cancel. I have hours. Perfect. Bottom is done. Check. Okay, now we're going to have to work on these revolutions. I want revolutions into miles. Is miles an angle or is that a length? Well, that's a length. Okay, so that means we're going to have to do circumference here at some point. Revolutions need to go away, so they're going to go on the bottom. So 1 revolution. What's a revolution? A revolution is 1 time around the circle. So 1 revolution, I look at my circle, I'm going to have to do circumference. 2 pi r, and then you have to put a unit. This is a unit conversion. Without units, this table is useless. The units here are feet. Okay, 2 pi r feet. So the revolution cancels. Great, now we have feet. Wait, I didn't want feet, I wanted miles. Okay, that means you want feet to disappear. Feet are going to have to go on the bottom. Miles will go on top. And whoever is larger is going to get the 1. 1 mile has how many feet? Oh, everybody knows. It's 5,280. If by chance you did not know that, then you should definitely put that in a colored pen and memorize that fact. Okay, any number on top is going to get multiplied, multiplied, multiplied. Any of the numbers in the bottom have to get divided. This is clearly going to be a calculator section. So we're going to type that all into your calculator and we're going to round nicely to 2 places. So please take out those calculators and practice with the buttons. Okay, did you do it? I'm waiting for you. Okay, you did it now? All right, let's see. Did you get 25.70? And I'm going to say miles per hour, mph. Perfectly done. You do not have to memorize any formulas. You just have to know how things are related with units. All right, let's practice some more. A radial arm saw. That's a circular saw that has a circle blade. Let me show you what these things look like. They kind of go, it's got lots and lots of sharp pointy teeth here like that. Okay, and it has a diameter of 10 inches. Ooh, I know where some people might make a mistake. Since the diameter is 10, I'm going to say that the radius is 5 inches. Be careful there of diameter versus radius. Okay, it spins at 3,000 RPM. RPM, that's revs per minutes. Okay, that's what I have. If there are 11 cutting teeth per inch, that's nice. Wow, that means there's 11 teeth in just 1 inch. How many teeth cross the cutting surface each second? So I need to turn revs per minute into teeth per second. Well, that's a little unusual, but that's okay. I have my circle drawn, and I have my goal. I have my starting fraction and my ending fraction. So let's go ahead and start with a conversion table. I have revs per minute. In fact, we have 3,000 revolutions per minute, and we have to convert that. Do you want to do revs first or minutes first? You want to do minutes first and the seconds? Okay, then minutes have to get out of there. Minutes are going to go in the numerator, and we'll put seconds in the denominator. Since minutes are bigger, 1 minute has how many seconds? Yep, 60 seconds. Minutes will cancel out, and I've got my seconds. Okay, I'm halfway done. Now I have to get revs turned into teeth. So 1 revolution. 1 revolution. It's usually 1 revolution. So look at the circle. Go around the circle 1 time and tell me how you're thinking about this. Once around the circle. I'm thinking circumference. I'm thinking 2 pi 5. I need some units here. Inches. Okay, perfect. I've got inches. Oh, but I needed teeth. Okay, so inches are going to have to get out of there. I have to put inches here. How am I going to turn inches into teeth? Well, wait a minute. Look at this fact. 11 cutting teeth per inch. There's 11 teeth in 1 inch. That's how you're going to do it. Okay, so you're going to take out your calculator. You need to multiply 3,000 by 2 times pi times 5, and then you're going to divide it by 60. Please type that all in and round perfectly and show me your calculation skills. The correct answer is 17,278.76 teeth per second. It's okay to have half of a tooth. It's not a live thing. That's not gross. Okay, let's move on to the propellers of a ship. Okay, the first thing I need to do is draw a circle. Have you ever seen a propeller of a ship? It kind of looks like there's like 3 of these arches like this, and then they spin round and round and round, and when they spin, they're essentially going to have the shape of a circle. Okay, so it's a fancy circle. And the radius is 1.3 meters. Okay, at full throttle, the propellers turn at 140 RPM. What's an RPM? That's right, revolution per minute. Okay, that's what we have. But they want to know the angular speed. Angular speed, that's an angle in, oh, thank you for telling me, radians per second. Okay, I think we're ready to start. We have our diagram and we have our goal, our conversion goal. So let's go ahead and draw a conversion table. We're going to start off with revs per minute. How many? 140 revs per minute. Okay, should we do time first? Minutes into seconds? Minutes need to go away, so they're going to go up here. Minutes into seconds. 1 minute has 60 seconds. Cancel minutes. Perfect. We're halfway done. Now I need to get radians. Revolutions are in the numerator, so I have to put 1 revolution in the denominator. 1 revolution. A revolution is once around a circle. And I need to turn that into radians. Okay, I'm going to put a little note here. Radians is an angle. That's an angle. I don't want a distance. I don't want meters. I'm not going to do circumference. Does anybody know how many radians are in a revolution? Once around a circle is how many radians? If I said degrees, you'd say 360. But how many radians? The answer is 2 pi. That's it? I don't need 1.3? No, not in this example at all. So we're going to go ahead and type that in. And the answer is 14.66 radians per second. Sometimes when it's so easy, people get scared. Okay, but don't get scared. Okay. For this next example, ZZ is racing on a bicycle with a 10-inch radius wheel. So let's go ahead and draw our circle here, and the radius is 10 inches. When she is traveling at a speed of 25 feet per second, so it seems like we're starting off with feet per second, how many revolutions per minute are her wheels making? So we need to convert that into revolutions per minute. Okay, we're ready to start. We have our circle and we know what we're trying to convert. Let's draw our conversion chart, and we'll start off with 25 feet per second. Okay, let's go ahead and get those seconds taken care of. Seconds need to cancel out, so let's put them in the numerator, and we're converting them into minutes. That'll go down there. 1 minute is larger, having 60 seconds. Perfect, we have our minutes. Okay, let's talk about feet. Feet has to be converted into revolutions. Revolution means go look at that circle. You have to go around it to be a revolution. But wait a minute, feet? This circle's in inches. So I'm not quite matching up here with feet and inches. So guess what we have to do with feet? That's right, we're going to have to put feet down here, convert feet into inches, then I can talk about that circle in inches. 1 foot has 12 inches. Okay, feet have been canceled out. Now we're left with inches. So now I can talk about this circle. The circle has inches. We're going to put inches in the denominator, and I can talk about 1 revolution. Once around this circle, in terms of length, would be 2 pi r, or 2 pi 10. Now I really want everyone to take out your calculator and try this calculation. When you have 3 things down here like this, you have to be very careful in your calculator to make sure that it knows to divide by all 3 of them. If you just say divide by 2 pi 10, it will divide by the 2, and then that other 2, the pi and the 10, will get in the numerator. Okay, so please take out your calculator and practice typing this in. Really, go ahead and practice typing it in. There's no reason why you should get this wrong on a test if you know exactly what you're doing. Okay, you have an answer? It should start with 200 and something. Good, you got something like that? 286.48 revolutions per minute. Maybe I'll say RPM. You don't have to say RPMs. You could say revs per minute, but that's what that means. Okay, great work. Let's do the last example here. A truck has wheels that are 36-inch, oh, careful, diameter. So let's go ahead and draw our circle with a radius of 18 inches. Okay, the wheels are rotating at 630 RPMs, revolutions per minute. I think it's time to stop telling you that. You should know that. So we have revolutions per minute, and we're going to convert that into, let's see, the speed in miles per hour. Miles per hour. Make sure you put MI because M means meters. Okay, let's go ahead and get started. Once again, we're going to draw a conversion chart. We have how many revs? 630 revolutions per minute. Okay, let's do minutes converted into hours. We'll put minutes in the numerator. 60 minutes are in 1 hour. Cancel minutes. We have our hours. Check. Now let's do revolutions. A revolution in the numerator here has to go in the denominator to cancel out. 1 revolution, once around the circle. Should I talk about it in terms of length? Should I convert it into length? Let's go take a look. It says miles. That is definitely length. So I don't want to convert a revolution into degrees or radians. I want to do length. Once around this circle would be 2 pi 18. Make sure you put a unit here. Inches. Make sure you put a unit. These conversion charts need units. So revolutions are gone. Oh, but wait a minute, we're not done. Inches needs to get converted into miles. So inches are going to go on the bottom. And inches cannot go directly into miles, but I know that it can go into feet. 1 foot has 12 inches. Inches, goodbye. Oh, now I got to get rid of that feet. So I'll put feet in the bottom, and I'll put miles in the numerator. Perfect. 1 mile has, what's that magic number? Go ahead, say it. 5,280. Okay, once again, I want to see if you can practice typing this in. There's 2 numbers in the denominator. Make sure both of them get divided. Okay, and the correct answer is, it's going to be in the 60s. Go ahead, type it in. 67.47 miles per hour. Okay, good luck, class. Do those conversions.